So in this video, we'll learn about flowcharts, pseudocode and algorithm. We are yet not jumping directly onto the code because we first need to make a thinking process of how to think when we are approaching a program. And the first thing is a flowchart. Now, whenever you see a question, what first happens is you try to visualize the flow of it. And that visualization is done using flowcharts. So let's see a question. Let's come to this screen later on. Let's see this question. We have to take a name and then we have to output hello name, right? So let's see what we first need to do. We need to have a name. Okay, so we are starting the program. Now the first thing that we need is a name. So we took the name as input. Now we have to print out a hello name. So for that we need to do some operation. We need to add hello and name. So okay, let's just create a string where we have hello plus the name. Okay, done. Now what we need to do? We need to have the output. So let's output hello name and then the program is ending. Now this visualization is done using flowcharts in our brain. We are not going to just make flowcharts every time on the paper, but we are going to visualize it in our mind. Let's come to this question. Let me first tell you about the symbols that we have for flowcharts. So for starting and stopping, we use oval. For input output, we use parallelogram. For processing, we are using the rectangle. For condition, we use rhombus. And the arrows are used to show the flow direction of a program. Now, the important part over here is this question. Take input of a salary. If the salary is greater than 10,000, add bonus as 2,000. Otherwise, add bonus as 1,000. Okay, so this is a question. Let's see the flow chart of it and let me tell you how we are going to approach it. So what we need to do first, input of a salary is there to be taken. So we start the program, we'll take the input of the salary. Now, the salary is greater than 10,000. Okay, so there is a condition. So if salary is greater than 10,000, there can be two cases. It can be either true, it can be either false. Now, if it is true, we'll say bonus is 2,000. Add bonus as 2,000, otherwise add bonus as 1,000. So it's true, the bonus is going to be 2,000. Okay. What if it is false? If it's false, then the bonus is going to be 1,000. Done. Now, what needs to be done next? We need to add it. So the total is going to be the salary plus bonus. Then we will output it, output the total salary, and the program is going to end. So now you can see that the program is flowing in a structured manner. So this is basically done using flowcharts. Let's see one more question, which is to find whether a number is prime or not. Okay, so how can you say if a number is prime or not? So for a number to be prime, for a number for a number to be prime, it must exactly okay, for a number to be prime, it must exactly have two factors of it. Two factors of it. पहला factor क्या होता है? It is one and the number itself. So now we know कि we have to find a number which has only two factors, which is one and the number itself. So let's see about the conditions. The first condition can be the number that we have is less than 2. Second condition can be the number is equals to 2. And the third condition can be that the number is greater than 2. Now we know that 0 and 1 they are not prime. So if the number is less than 2, what we'll do? So the number is less than 2. Okay, true. So what? The result is not prime. Done. And we are going to output the result and the program is going to end. Okay, great. Now what if the number is equals to 2? That means number is not less than 2. So we come to here. Number is equals to 2. Is it no or is it yes? If it is yes, we know that 2 is a prime number. Okay, so 2 is a prime number, the result is prime. So output the result and the program will end. Now the third case, is the number greater than 2? Yes, it is true. So firstly, we'll do the modulo. If n modulo 2 equals 0, now what modulo does is, it will give you remainder. We have two operators, one is division and one is modulus. So division gives you the quotient. Like for example, we are dividing 10 by 2. So when we divide 10 by 2, the division will give us 5 because 2 times 5 is 10. But if we find modulo, so 2 modulo 10 will be 0 because modulo gives us a remainder. So if the modulus is equal to 0, that means we found another factor. So what we are going to do? That It is 0, so it is not prime because now we have more than two factors. So we are going to say not prime, output the result, and the program is going to end. Okay, and modulo 2 is not equals to 0. Then let's set the divisor to be 3. Okay, we set the divisor to be 3. Then we have a condition for a loop over here. I'll tell you more about this program, that how the loop is actually working. Let's first see the condition. So I multiply I is less than equals to number that we selected. If it is true, then we are going to divide the number by I. I mean, we are going to take the remainder of the number with I, and so we did again n modulo I. Is it equals to 0? If it is equals to 0, then we got another factor. If we got another factor, then the result is not prime and we'll output the result. But if it is not equals to 0, we are going to say increment I by 1 and then go back to this condition. Is I multiply times I still less than equals to n? If it is less than equals to n, then we are going to say again n modulo I double equals 0. If it is true, result is not prime. And it is going to run for all the numbers which are less than n, like which have a square less than n. If it is false, wherever it becomes false, so the result will be prime, because if it would have been true even once, then we would have got a not prime. So if it is false for the first time, then the result is prime and we'll output the result and the program will end. So this is flowchart, and I think you pretty much would have understood about flowcharts now. So now the next thing that we need to see is algorithm and pseudocode. Now, right now we understood about flowchart. So this process that we understood in the flowchart to find whether a number is prime or not is the actual algorithm. For example, start it, take an input, check if it is less than 2, or it is equals to 2, or it is greater than 2. So this whole process of finding a prime number is the algorithm. And when we write it visually, then it is a flowchart. When we write the algorithm in English, then it is pseudocode. For example, if I'll write over here, so what it is going to be? Let's see. Let me zoom in a bit. Take input of number, let's say n. What after this? Check if n is less than 2. If it is less than 2, output not prime, and then we will just say it to end. And now we see n is not equals n is not less than 2. Now check n double equals to. If this is true, then we will say output n is prime, and then we'll end the program. Now the third condition, which is check n is greater than 2. If n is greater than 2, then we'll see a loop while I starting from 2, I equals to 2. And we'll go till where? Till I is less than n. If this is true, then we'll say ki if n modulo I equals 0, if this is true, then we'll say output output n is not prime, and we'll end the program. If the condition is not true, then what we'll do? We'll say I plus equals 1, I equals to I plus 1, and then the loop will keep on going till I is not less than n. And once we come out of the loop, we'll say ki we come out of the loop and the loop did not break. So what we'll say? We'll output n is prime. Now why we are outputting n is prime? Because we did not have any number which divided n perfectly and thus would have been a factor of n, because we are going till I less than n. So n is prime. and then we'll end it. So this plain English in which we have written our program, this is called as pseudocode. And when we are visually representing it in this way, uh, laser pointer, yeah. So when we are visually representing it in this way, then this thing is called as flowchart. Now, when we are writing it this way, then this is called as pseudocode. So both are same. We are just having a way of writing it. So this is basically used when we want to visualize the problem. And when we write it down step by step on a paper, then we usually do it in the form of pseudocodes. So I think you must have understood about pseudocode, flowcharts, and algorithms. Now, if you have any doubt, the comment section is open. Make sure that you are following with me because this is a course which is starting from the scratch and we'll go till the position where we can crack any interview. So make sure to comment if you have any doubt and I'll make sure that I am answering each of your comments. And this is the best DSA course that you will find. That is what I'll promise to you guys and I'll make sure that I deliver my promise. So till then, keep learning and we'll meet the next time. Sayonara.